So here's a quick rundown of how you can use a graphing calculator for your function and an average rate of change function. And then I'll give you a couple of different ways to evaluate. Probably just use a table is the easiest way to go about doing this. But let's say that you wanted a function that you were trying to find an average rate of change for. So the first thing you'll want to do is put that into y1. So I'm going to go ahead and find an average rate of change of 2x squared. And then you'll need to write another function that's based on this one. So we're going to find average rates of change of 2x squared, but we're going to do that at x equals 3. And this is just an arbitrary number that I've chosen. So we're going to do an alpha y equals, that gives us a nice looking horizontal fraction bar. But remember, if you've got an older calculator, you'll have to just use parentheses and a regular division symbol. So then what we're going to do is we're going to do the function that we've got. So I could type in 2x squared here if I wanted, but since I've already typed in the function up here in y1, I'm going to do, there's a shortcut, alpha trace gives me all of my functions, so I'm going to do y1 of x, so that's the same thing as like f of x, minus y1 of, remember I said we're going to do this at 3, so this is a pretty simple function. Hopefully you can do 3 squared times 2, so we know this is going to be 18, so you could either type it in that way or you could type in y1 of 3. And so for the fun of it, let's actually go ahead and type in y1 of 3. And then in the denominator, we will put in the x minus 3. So here I have a slope formula that represents the average rate of change. And then, remember, we're trying to find average rates of change around x equals 3. So the best thing to do, I could do this from the home screen, just evaluate y2 of different numbers. So I could come back to the home screen and I could do y2 of, first of all, we'll do y2 of 3. Hopefully everyone watching this video understands why I'm going to get an error here. That's because I'm dividing by 0. But I could also do y2 of a number really close to 3. So like we could start with 2.9 for instance. And I'm going to get 11.8. And then I could do like 2.99, which is even closer. And it looks like we're close to 12 on that side, but we should also, remember, we always want to check on both sides. So we'll do like 3.01, and then sure enough, it looks like we're somewhere around 12. Now, an easy thing to do here to just kind of speed the process up is to do second window, and that takes us to our table setup. And we'll come down here and we'll change the independent variable to ask. This was described in the notes. And so we're going to do an independent variable. We're going to do ask, and then we're going to go second graph, and that brings us to our table. And here's where you could plug in numbers that are around 3. So I'm going to do like 2.5, and then 2.9, and then 2.99, and then 3, just to see that error, and then 3.01, 3.1, and 3.5, just to keep some symmetry. I'm checking numbers that are equidistant on both sides. So sure enough, you can see from this table, so remember, these are the actual values of the function. So this is just 2x squared. These are points on the graph of 2x squared in this column with y1. And then these are the average rates of change around 3. And you can see that it looks like it's going to be 12 for the instantaneous rate of change. All right, folks, hopefully that helps out.